All right, so we're back to chapter 1. It's been forever, I think, right, since we've done chapter 1. So let's take a look at it. What's going on here? What's this? So look, that 3x stayed here, that 3x stayed there, so we didn't really do anything there. What did we basically do here? Yeah, just switch the order, okay? When you just switch the order, okay, you can go back and forth, back and forth. Like if you have a job and you go back and forth to your job, what are you doing? You're commuting, right? So that's the commutative property. I kind of doubt I'll put a property question on there, okay? But that's what it is. All right, let's do these. Here we go. We got absolute value. We've done a lot more complicated things with absolute value since then, but this is your basic stuff. So let's do it. 3 minus 15 is? 3 minus 15. Negative 12. But it's an absolute value. So what is that? Listen, let's go one step at a time. Okay, don't get ahead of me. So 3 minus 12 is, 3 minus 15 is negative 12. The absolute value is what? 12. But you got this negative right there, which turns it back into a negative 12. All right, so we don't want to do too much in our head. So the top, that part right there is going to be negative 12. What about the bottom? What's that going to be? Is it going to be a negative 4 or positive 4? It's negative 4 because you're not squaring the negative here. What if, it's not, but what if it was in parentheses? Then it would be a positive 4, okay? But it's not, so it's just a negative, what? 4, okay? Let me have it. Let me have it.
Just check my message.
I don't care. Let me have it. Didn't ask what you were doing with it. Negative 12 divided by negative 4, what's that? Positive 3. Plus 7 is 10. Easy. What about this one? Here we go. Let's zoom up a little so we can see it a little bit better. Let's make this a little smaller. There we go. Okay, so what do we do here? Well, the first part's easy. Look, x to the fourth, x to the fourth. One's on top, one's on the bottom. What's that? Just cancels out to be a 1, doesn't it? Yep. All right. Hunter, what'd you say? Z to the 0. What's z to the 0? It's a 1. It's just a number 1. It's not a 1z. It's not z to the first. It's just the number 1. It's being multiplied. Don't need it, right? What do I do here, though? There's a couple things you could look at it, but there's a couple ways you could look at it, but here's what I would do. I got that negative exponent. I don't want negative exponents, so I'm going to take this, flip it to the bottom. Once I flip it to the bottom, what do I do to it, though? I got to do something to it. Well, not yet. I got to change the sign of the exponent. Okay, so make it there. So we got rid of it from the top, took it to the bottom, but when you do that, you got to change the sign of the exponent. You with me? Yep. All right. So now, look, everything's canceled on top. But when I canceled it, really, it went one time, didn't it? Okay, and then, so what do I have left on top? A 1 over, what's this going to be? It's just y to the 8th. Y to the 4th, y to the 4th is y to the 8th. What do I do? What's the rule when I'm multiplying, but I got exponents? Multiplying the same base, you add the exponents. That's why it's an 8. It's not a 16. It's not 4 times 4. Everybody see that? That's a common mistake. Say what? If it's to another power, right? Like right here. Okay. Everybody good? All right. Let's do this one. Let's do this first. Now, am I going to do this? Am I going to cancel out 3x and 3x? No, because there's other stuff that's happening. Okay. What I like to do is simplify the top. Let's simplify the bottom, and then if you need to flip stuff, then we'll flip it then, okay? Just not right now. Again, there's several ways you could approach this, but here's how I'm going to do it. So I've got 3x, that right there. What's this going to be? That's x to the first, right? So this is x what? To the second, or x squared, right? What's this going to be? Right. This is when you multiply the exponents. When you have an exponent taken to another power, that's when you multiply the exponents together. Everybody got that? Okay. Tell you what, let's finish up the top and then we'll do the bottom. Nah, let's not do that. Let's just do it like this. Let's do the bottom now. What's this going to be? Everything in here is being taken to the negative first power. So what's this going to be? 3 to the what? Negative first. then this x is going to be x to the negative first. What about this one? Y is going to be to the what? Positive second, because again, when you have an exponent, take it to another power, you multiply the exponents together, negative 2 times negative 1 is positive 2. Okay? Now, what are we going to do here? I can do a couple things. Can we do all this at once? I don't know. Can you handle it? Watch. We're going to take this. We're going to move it to the top. Why? Why are we going to take this and move it to the top? Because it's got a what? It's got a negative exponent, right? So if I move it to the top, I get 3, or 3 to the first, correct? This goes away down here. I moved it to the top. What do I got here? I got x to the negative first, correct? What am I going to do to that? Move it to the top. So I got another x, don't I? All right, so it's going to be x times this x times x squared. I don't know, is this going to confuse you if I do this? I got an x times an x, so what's this going to be? X squared. Does that bother you if I do that?
No.
Just kind of shorten it a little bit. All right, what about this? So 2 of these y's cancels with what? 2 of those. How many do I have left? 4. So that's kind of how I look at it. Now, looks like a jumbled mess right now, but let's fix it up. Do I have anything on the bottom at all? No, everything canceled out. So there's just a 1 on the bottom, okay? Let's multiply. So I got 3 times 3 is 9. Then I get x squared times x squared is x to the 4th. And then I got y to the 4th. Okay? And that's it. Right? It's not so much.
It's not like no work at all. What are you talking about?
But you got to practice it. Look, if you just sit there, and that's what everybody's doing. Everybody's just sitting there staring at me. Is anybody writing this stuff down? If you're taking, yeah, sure you do. Yeah, I'm recording it, but still, you should be writing it down. I mean, why bother? Are you really going to watch it?
Yes, I promise you all watch it. I watch almost all the videos.
Are you going to write it down? Are you going to take notes on it after when you watch it? I doubt it. If you're not taking notes now when I'm begging you to do it, you're not going to do it on your own. Sure you will. Why don't you do it right now, though? No extra credit. There's no extra credit in here. There's regular credit. Because it's regular credit. So look, we're going to distribute the 2x through both of these. So what do I get? 6x squared plus times this, 8x. What are we going to do with that negative? Distribute the negative, through everything. Okay, so I get negative 3x squared. What's this going to be? Minus 8x. What's this going to be? Plus 2. So that was easy. We all got that, right? This is all basic Algebra 1 stuff. All right? I guess this is Algebra 1. Did you do that in Algebra 1? No. Probably did.
Wait, question 4, question 5.
4. Yeah, you probably did that in Algebra 1. You should have. That's okay. I taught it in here. So you've had it. 6x squared minus 3x squared. We're adding like terms, which is 3x squared. Watch. I like to mark them off. Then positive 8x minus 8x is 0. It's not nothing. It's 0. And then that's what? Plus 2.
So, Mr. Hammer.
What?
Why did the mathematicians create the fake number system instead of just saying
The imaginary?
Yeah.
Because people use imaginary numbers.
But how? They don't exist.
The word imaginary doesn't mean it doesn't exist.
What?
In math, an imaginary number doesn't mean just a made-up number. It's a number. You got real numbers, you got imaginary numbers. Real numbers lie on the number line. Imaginary numbers don't lie on the number line. There are reasons for imaginary numbers. I took a whole class. They called it complex analysis. That was the name of the class. How would you like to take a class? It's called complex analysis. But basically, it was like doing math. Shh. It'd be nice if you listened to me instead of talking. I'm telling you, before I started doing media arts and I was teaching math, not all the time, but most of the time I could talk and people weren't interrupting me all the time. I came back and then it seems like every time I talk, somebody yap, 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 yap. Like there's no issue with it. There's an issue with it, okay? Maybe because your teachers don't tell you. Maybe they just let you talk. I don't know. Do they? Do teachers just teach and let everybody just talk and blab on? I can't imagine. I can't imagine that. So I don't do that in here. So let's listen. Here we go. Let's do this. Don't worry about it. Okay? Is that going to help you on the test? It's not going to help you on the test. So don't worry about it. We'll get it later. We'll have a chapter, at least a chapter on imaginary numbers. Okay? So we'll do that stuff. We'll talk more about it then, but not now. Here we go. P to the third. So you look right here. You've done this kind of stuff even lately, right? When you plug stuff in. Remember we did that f of xy, plug stuff in. It's basically the same kind of thing. So p cubed, which is what? 2 cubed minus 3 times y squared. So put that in parentheses and square it. Minus 2 times m. m is -4. Okay? It's easy, just substitution, basic substitution. 2 cubed is 8 minus, can we do this in our head? 3 squared is 9 times 3 is 27. And then right here, multiply those together, plus 8. All right? And what do you get for that? What number are we on? 6? Okay. 16, I'm going to do it like this. 16 minus 27. Would you agree? 8 plus 8. And that's what? -11? There we go. It's a little easier way to do it. All right, now we actually solved. Now look, we're solved. Solve. So we got to get x by itself now. So these are just all simplifying. Some people might say simplify. This book says evaluate. But let's do this. So before we actually start getting x by itself, you got to simplify both sides. So let's do that. So let's do this over here. So 15x plus what? 60 equals 7x plus 20. Get the x's on the same side, subtract the 7x. I'm not going to show the work, let's just do it. If I subtract 7x, what do I get? 8x. Subtract a 60 from this side, what do I get over here? -40. And then divide both sides by 8, and then what do you get? -5. Whoops. This is a stupid button on this pen. When I put my thumb on there, I try not to, but you know, the pen moves around and then it does that weird stuff. All right, so there you go. Easy, right? Oh, this one looks more difficult, doesn't it? But is it? Maybe. I don't know. I'll tell you what, let's get rid of all this stuff just so I have some room. Because these tests were not designed to write on the test. That's why I give you the answer sheets. There we go. All right, here we go. Let's do this so I have some room. All right, so let's do this. Let's distribute. Yeah, let's do it. Let's distribute. What do we get? 3z minus 1. 3, thank you. Almost messed up already. Minus, what's half of 4z? 2z. And then this is going to be minus half of 10 is 5. All right, no biggie. Equals, let's distribute the 4. So that's a what? 4z. Is it? It's minus, right. That 2 goes into that 4 twice. 2 times 3 is 6. Right? And then you got the plus 10 on the end. All right, let's add some like terms. 3z minus 2z is 1z. -3 minus 5 is -8. And then right here is just 4z. And then plus 4. You could take the 4z over here. You could take the z over to the right. If it was me, I would subtract the z from both sides. So subtract the z. Just to make sure, just to keep it positive. That's the only reason. Get rid of the 4. So I got what? 3z equals -12. Divide by 3. Z is -4. Easy peasy. Okay. Inequality. There's one little trick that we got to remember with an inequality. What's that? When what? When you divide or multiply by a negative, right, okay? If you don't divide and multiply by a negative, don't worry about changing the inequality. Just keep it the way it is, okay? So work with it just like it's an equal sign, except when you have when you got to multiply or divide by a negative. So can we fit this in here? 3x minus 6 is greater than 5x plus 6. Now this time, with an inequality, I really like everything on the left-hand side, my variables, okay? I like the variable on the left-hand side. It's just a lot easier to read from left to right when you do an inequality. Would you agree with that? No, don't answer. Minus 5x from both sides, so what do we get? Negative 2x. So that gets rid of that. Add the 6 to both sides, we get 12. Now, have we, up to this point, have we multiplied or divided by a negative? No, so we keep the inequality the same. But you're right, we're about to now. So we divide by a negative 2. So if I divide that by negative 2, that'll cancel out. Divide this by negative 2, I get negative 6. But what do we do? Since I divided by a negative, I got to change that and put it in the other direction. And that is our answer. Okay? That's really the only thing different about that. All right, let's do this. 3x plus 12 plus 2x minus 4 greater than or equal 4x minus 5. Okay, add like terms. 5x plus 8 subtract a 4x from both sides, I get x. Subtract an 8 from this, I get what? Negative 13. Have I divided or multiplied by a negative? No, I subtracted. That's good. I'm okay with that. So I don't change the inequality. I just keep it the way it is. And that's your answer for that. Easy stuff, isn't it? It's all Algebra 1. Remember when I first did this chapter, I'm like, are we ever going to do any Algebra 2 stuff? Remember that? All right. But really, this whole chapter, if you had a decent Algebra 1 class, this whole chapter is basically Algebra 1, okay, if you had a decent Algebra 1 class. All right, let's do this. And we got to do some graphing. Graphing should be a piece of cake now, shouldn't it? Well, actually, this graphing's a little, well, some of these, yeah, this graphing's a little bit different than what we've been doing, all right? So let's do this. You got an or right there. So here we go. Let's add an x to both sides. So what do we get? 4x. Subtract an 8 from both sides. We get a 4. Right? We keep that right there. X is greater than what? 1. Okay, or let's do this. Let's add a 2x to both sides. So we get a negative 3x. Subtract a 7. What's that? 9. Still greater than, correct? Divide by a negative. So you got to change the inequality, divide that by negative 3, and you get a negative 3. Okay? Now, to graph the thing, this is not, I don't know. Yeah, it's not a graph on the Cartesian plane. It's just along one axis, okay? So we can just do this. Yeah, we talked about that. So watch. There's a 1. So x is greater than 1, right? So if it's just greater than, it's what kind of circle? Open. Remember that?
Yeah.
And then it's everything shaded in that direction, all right? And then this says what? X is less than negative 3. So it's open again. And it's everything shaded in this direction. And there's your graph right there. No biggie. We good with that? Yeah. Oh, what about this one?
Absolute value.
That was that, okay? This one, we got to do 13. What's crazy?
Imaginary numbers.
Are they?
Like how low they get.
How low?
Do they ever start to fade?
I don't know what you're talking about.
It's not funny.
Was that a joke?
Yeah, we only have to get it.
What was it, Jeremy?
All right, because they're imaginary, they don't exist or something. All right.
It's always
All right, what we can do here, you can do a couple things here. You could rewrite these as two separate inequalities if you wanted to, couldn't you?
Yeah.
You could write it like this, right? Okay. And then you could also write it like this. But let me show you a better way, especially on this one. This one's kind of easy, so we can do it. Watch. How do I get this x in the middle by itself? Well, you know what? Let's do, I changed my mind. Let's, let me see what I did. Yep. Let's do what I just said. All right, so what do I got? I got 2x plus 1 is less than or equal to x plus 5. All right. This is an and. When they go together like that, they're not separated. They kind of go together. All right, and then what do you got? You got x plus 5 is less than or equal.
Thank you.
All right, and now we just solve for x. Okay, so let's subtract x from both sides. So we get an x, correct? Subtract a 1, we get a 4. We didn't divide or multiply by a negative, so it's just x is less than or equal to 4. Let's do this one. Let's move the 3x over to the left-hand side. So that gives, if I subtract it, so what do I get? Negative 2x. Let's move the 5 over here. We subtract a 5. We get negative 6. Still less than or equal to. Now we divide by a negative. If you divide by a negative, you got to change the inequality. Divide that by a negative 2. Divide that by a negative 2. That's a 3. But look how we write this. You guys listening? No, you're not. X is less than or equal to 4, and x is greater than or equal to 3. So when you do the solving, it's much better if you write it like this. So what does that mean? X is between 3 and 4, isn't it? You see that? 3 and 4. So what does it say? X is less than or equal to 4, and x is what? Greater than or equal to 3. So this is the best way to write your answer. Says the same thing, doesn't it? Yeah? Yeah, you see that x is less than or equal to 4, but this one, I just kind of switch it around, right? X is greater than or equal to 3. If I read it from right to left, isn't that what it's saying? X is greater than or equal to 3? Yeah, but that's an and graph. And if you're to graph it, super easy. So there it is. So where do we put our numbers? 3 right here. Put 4 right here. It's or equal to. What kind of circle do we put if it's or equal to? Closed circle. And we shade everything in between. Okay? All right. What about this one? Well, can't really do anything. Let's change this. Why did it go back to that? So watch. Negative 2x plus 5. It's an absolute value. What's this going to be? Absolute value negative 11 is 11, but you got a minus 11. So this is a minus 11. Let's get rid of it right now. I think we can do that, right? How do you get rid of a negative 11? Add 11. So what's this equal to? 6. Okay? So what we're going to do, this is an absolute value. So what we're going to do is we're going to write it without the absolute value. Watch carefully because it's been a while since you've done these. You got negative 2x plus 5 is equal to 6. And what else? Negative 2x plus 5 is what? Is equal to negative 6. That's right. Okay, that's the definition of an absolute value. I'm not going to go through why, it's just how you do it. And then you just go through and you solve for your x's. You can do that on your own, can't you? So x is negative 1/2 right here, and x is 11 over 2 right here. So those are your two answers. Right? Subtract a 5. It's negative 1. Divide by 2. Or it's positive 1. Divide by negative 2. It's negative 1/2. Right? You can do that on your own. Yeah. All right, let's get rid of all this. Where are we at? Okay, let's do this one. How do we do this one? Well, kind of the same thing. So it's 3r minus 1 equals what? Just 5r plus 3. So you just write it without the absolute value. But then you got to change something. Okay, put an and. What? 3r minus 1 equals what? You got to take that whole thing and take the negative of it. So what's that going to give you? Negative 5r minus 3. Correct? All right, so, and then we just do the math. Subtract a 5r, negative 2r, add a 1, it's 4, divide by negative 2, so r is negative 2. Then right here, let's see, add a 5r, you get what? 8r. Add a 1, you get negative 2. Divide by 8, so r is negative 1/4. But if you remember, it's been a while, so you might not remember, but you need, when you have these things right here, you really should check them. So, actually, I'm not going to circle that yet. Let's put it in and see if that actually works. Okay? Let me get rid of this mess. These little things right here. Okay. Let's put them in and see if it actually works. Let's put in a negative 2 in for this. You watching? Gotta tell you every second, don't I?
I'm sorry.
So look, 3 times negative 2 is what? Negative 6. Negative 6 minus 1 is negative 7. Absolute value is 7. Let's put a negative 2 in for this and see if it works. 5 times negative 2 is negative 10. Negative 10 plus 3 is negative 7. Do they equal each other? No, they don't. So I am not going to use that as one of my answers. So that is not a possible solution. Even though the math works out that way, you got to plug it back in. All right? You could do this if you want. All right? This does work. All right? So that's the one we're going to keep. I'm looking at time right now, okay? All right. Let's get rid of that. Oh, what do I hit? I hit that. Then this. Okay. What are we on? 17? So we got 2 more to do, right? Plus the graphs. No big deal. So we got an absolute value again. So we just kind of do the same thing that we just talked about. Yep. So let's do it. 2/3 x minus 5 less than or equal to 3. Then, and we also write 2/3 x minus 5 less than, oh, you got to be careful though. When it's an inequality with an absolute value, okay, what do we do to this inequality? I almost forgot myself. You got to change the direction of the inequality because we're basically multiplying it by a negative. All right, so you got to change the direction of the inequality. So that's one little step that might be easy to forget that is good to know. You could mess the whole thing up exactly because of that. Now, again, I am not going to do the work for you. You can do the work for yourself. So it comes out to, what number is this, 17? Comes out to 3, I think. Does that first one come out to 3? No, the first one comes out to 12. Yes. The first one comes out, let's just do it. All right, add a 5, because we do have time, actually. If I add a 5 to that, I get an 8. How do I get rid of this 2/3? Not just by 3 over 2, because I'm trying to get rid of both of the 3 and the 2. All right, so I come over here, multiply that by 3 over 2, put that over 1. So that all cancels, so x is less than or equal to, what do we do here? 2 goes into 8 4 times. 4 times 3 is 12. So that's one of them, okay? And let's do the other one. Add a 5. I don't have to show that. Add a 5. So if I add a 5 to this, I get what? 2. Multiply by 3 over 2. Multiply by 3 over 2. Cancels. X is greater than or equal 2, 3. There you go. Now, it's also important to take them and plug them back in and see if it works. All right? So make sure you do that. These both work. Okay? If you're to graph this, they ask you to graph it, so we might as well do it. Got a 3. That's going to go down here. Got a 12. It's going to go right here. Now check it out. X is less than or equal to 12. Correct? So it's everything to the left, and it's also what? Greater than or equal to 3. So what's shaded? And they're all closed in. 3 and 12 are or equals. And then, yeah, it's just in between. There you go. That's your graph. We good? One more. Let's get rid of this. All right, last one. Let's do this one. So we can simplify this right off the bat, can't we? What's this going to be? 11x minus 9. So it's, oh, why did it go to, let's make that smaller. All right, so absolute value of 11x minus 9. So this is what that would be. All right, so what do you do with this? Write it twice. First one, just keep exactly the same. Just get rid of the absolute value. And then what do we do for the next one? Change the inequality and then make that a negative. All right, do the work. Plus 9, what's that? 22. You remember this one? Okay. 11 divide. So x is greater than what? 2, right? Add a 9. 11x is less than, what's that? Negative 4 divided by 11. We didn't divide by any negatives, so it's just x is less than negative 4 over 11. It's kind of an ugly number. You need to check them, right? Put them both back in. Make sure they work. Okay, they do work. Spoiler alert. And then we graph. What's the smallest number? That's the negative 4/11. I don't even have to put it in between anything. Just put the number there. It's good enough. And then right here is 2. It says greater than 2. So what's that going to do? It's going to go this direction, correct? And then less than negative 4/11. It's going to go that way. So this is going to be an or, isn't it? All right. And there you go. Look at that. Finished a whole test and explained every problem to you in less than a class period. All right, we've covered everything now, okay? Every chapter we've done so far this year, we've covered in the last 2 or 3 days, and it's up to you now for those who are taking. I read off the list, right? Who's taking it? Who's not? Okay. And so just be ready for it. Watch the videos. Take notes on it, even though it doesn't look like anybody took notes today. Just don't understand, but that's okay, I guess. So take notes on it. Do the problems. That's how you study for a math test. People ask me all the time, every year, Mr. Hamrick, how in the world am I going to study for a math test? Go get the door, Gio. Tell her I can talk. Tell her I can talk. All right, so please make sure that you do that.